Hello, and welcome to Vandenberg Space Force Base on the central coast of California. I'm NASA's Megan Cruz, and you are watching the pre-launch news conference for the National Oceanic and Atmospheric Administration's, or NOAA's, JPSS-2 mission. JPSS-2 is the third satellite in NOAA's polar orbiting satellite constellation. The 36-minute launch window opens Tuesday, November 1st at 2:25 a.m. Pacific time, with NASA's Launch Services Program managing it. Once in orbit, JPSS-2 will help scientists better predict and prepare for extreme weather events, climate change, and so much more. And launching with JPSS-2 is NASA's LOFTID, or Low Earth Orbit Flight Test of an Inflatable Decelerator. LOFTID is a partnership with the United Launch Alliance to test whether an inflatable heat shield can survive the searing heat of re-entering Earth's atmosphere. This technology could revolutionize space travel. To tell us more about both JPSS-2 and LOFTID, we have this extraordinary panel of folks here today. First, to my left, we have John Gagosian, Joint Agency Satellite Director here at NASA. Next to him, Omar Baez, Senior Launch Director for NASA's Launch Services Program, giving a wave there. Gary Wentz, Government and Commercial Programs Vice President over at ULA. And next to him, Irene Parker, Deputy Assistant Administrator of NESDIS. Tim Walsh, JPSS Director, NOAA. Jim Reuter, Associate Administrator, NASA's Space Technology Mission Directorate. And then we have Captain Zack Zounes, Launch Weather Officer, also waving, thank you for that, with the U.S. Space Force. So each will deliver some opening remarks, and then we'll take questions for those here in the room. You can just raise your hand, but those on the phone, you can get into the question queue by dialing *1, and then those on social media, you can post your questions using the hashtags either JPSS2 or hashtag LOFTID. Okay, John, why don't you take it away?
Thank you, Megan. Good afternoon. I'm John Gagosian, Director of NASA's Joint Agency Satellite Division. Our division is part of NASA's Science Mission Directorate, and we manage on NOAA's behalf the development and deployment of operational weather satellites like JPSS-2, the third of 5 in the JPSS series. We've partnered with NOAA for more than 50 years on the nation's terrestrial and space weather satellites in polar, geostationary, and libration point orbits. Our partnership has been very successful, having launched over 60 satellites on behalf of the nation to improve weather forecasting, severe storm and hurricane prediction, and climate observations. For JPSS-2, NASA is responsible for the formulation, development, launch, and initial operations of the satellite. JPSS satellites form the backbone of the global observing system, circling the Earth from pole to pole and crossing the equator every 100 minutes to cover the entire planet twice a day. I'd like to thank our industry team members, Northrop Grumman, L3 Harris, Raytheon, Ball, and ULA, for their hard work and dedication that have enabled us to reach this point. NASA is committed to the continued success of the JPSS program and its final 2 missions, JPSS-3 and 4, which are currently in development. In addition, NOAA and NASA are together formulating the next generation low Earth orbit satellite architecture. I'd also like to highlight the interagency collaboration that will allow NASA and ULA to perform the low Earth orbit flight test of an inflatable decelerator, which Jim will describe in a few minutes. NOAA's cooperation has enabled this innovative public-private partnership to become a reality. Thanks, and back to you, Megan.
Thank you so much, and thanks for that shout out to our industry partners. Okay, next we have Omar. This is your last news conference. How are you feeling about that? He's retiring.
I'm feeling great.
He's such a pro. That's why. He's such a pro. He doesn't need notes.
So, Megan and John, you stole my thunder. That's all the information that you guys had was what I was going to present. No, in reality, super excited to be here. Super excited to be launching the last Atlas V from the West Coast, enabling ULA to have some huge capability out of here with their Vulcan vehicle. And not only that, but getting our JPSS-2 satellite up in orbit along with LOFTID. And hopefully it doesn't stay in orbit and comes back down into the ocean and proves some great technology for great things to come. The the other thing I want to mention is this is Launch Services Program, KSC's Launch Services Program's 100th mission since we started in the late 1900s. So super excited to be here, and something to celebrate. We actually got a T-shirt out of it that says 100. So that is super cool. If you could roll some footage that we have, and I'll talk to that. This is the JPSS satellite and the Atlas arriving on the Mariner. So that was this happened in August. We started the erection sequence here in late September, while the satellite, along with LOFTID, were in Astrotech. That's LOFTID there being lifted up onto the payload adapter fitting, and then JPSS-2 will go on top of that, or is on top of that. And that's the last of the 4-meter metallic fairings that this mission will fly on the 401. This was accomplished about 2 weeks ago, last Monday, not this Monday, Monday before they rolled out. They came out to Slick 3. They made it to the launch vehicle, performed the testing that has to be done after you mate the spacecraft to the launch vehicle. And this week we had our final readiness reviews, along with today. We did our launch readiness review yesterday. We did our mission dress rehearsal. And the teams are, this is a team sport. We have NASA, we have ULA, the range, Northrop, Goddard, Langley. It's all a team sport. And we're all ready to go. So the next steps for us is Monday, Halloween Day. We'll come in at night, hopefully not in our costumes because the gate guards won't let us in. But after trick-or-treating, we'll come in. The team will move the tower away from the launch stand. We'll get into fueling the launch vehicle, and hopefully get this thing out of here at 2:25 in the morning. We have a 36-minute window, so plenty of time to do that, and just looking forward to a great launch on Tuesday morning. Over to you, Megan.
Well, sad to see you go, but congratulations on your retirement and LSP's 100th mission. That's an amazing milestone. Okay, Gary, take it away. Can you beat that?
I'm not sure I can tell. First, Gary Wentz, Vice President, Government Commercial Programs for United Launch Alliance. Do want to congratulate Omar on his retirement. That's pretty significant, having over 30 years with the government, working launch services program primarily. So we've been very happy with the support and partnership from Omar and the team. So it's been a busy few weeks here at Vandenberg. A few weeks ago, we launched our last Delta IV Heavy off Slick 6 and came back, did a lot of preparations, worked with the integrated NOAA NASA team to integrate the spacecraft, and now we're here to scheduled on Tuesday to launch the last Atlas off the West Coast. So looking forward to that. The whole team here from United Launch Alliance is excited to be a part of this mission. It's bringing significant capability from an advanced environmental perspective, as well as was mentioned, the reentry capability that is key for our future going forward. First, I'd like to thank our mission partners, Launch Services Program. We've been a partner with them for over 16 years, launching critical and historical spacecraft. This is the 39th and final contracted launch with the Launch Services Program. We're looking forward to future business on Vulcan on both East and West Coast. After this launch, our team will phase into the modifications to convert Slick 3 to be able to launch the Vulcan Centaur from the West Coast. And as Omar mentioned, we completed the launch readiness review. The team's not working any issues, and we're on track for a 2:25 a.m. Pacific launch here from Space Launch Complex 3. I'd like to wish the Launch Services Program congratulations on their 100th launch, and thank you to all our mission partners that are key for us to be successful. So thank you. Over to you, Megan.
Gary, thank you. Okay, Irene.
All right. So we are now just 4 days away from the launch of NOAA's JPSS-2 satellite, the latest in a series of high advanced polar orbiting satellites, which are improving the accuracy and timeliness of NOAA's numerical weather models and the quality of its global Earth observations overall. As many of you may know, NOAA operates multiple types of satellites, such as Discover in deep space, which is at Lagrange Point 1, which is approximately 1 million miles from Earth. The advanced geostationary satellites like GOES 16, 17, and 18, which orbit in a fixed position over 22,000 miles above the equator. And then our advanced polar satellites, namely NOAA 20 and our NOAA NASA SUMI MPP, which circle the globe 14 times a day in a much lower orbit, approximately 512 miles above the surface. These satellite systems play complementary roles and are absolutely critical for NOAA to provide a complete picture of what's happening with the weather and the climate today, tomorrow, next week, and even longer. JPSS represents the latest and best technology NOAA has ever flown operationally in the polar orbit to capture more precise observations of the Earth's atmosphere, land, and waters that are improving NOAA's life-saving weather forecasts. And they also provide environmental information essential for the nation's economic security and development. JPSS-2 will join SUMI MPP and NOAA 20, giving NOAA the benefit of 3 advanced polar orbiting satellites in operation. Tim Walsh, the JPSS program manager, will go into more detail about the orbital assignments. Against the backdrop of the deadly destruction of Hurricane Ian in late September and Hurricane Ida in 2021, along with the destructive wildfires here in the West and in Alaska, NOAA's weather satellites have never been more critical as extreme weather events continue to be more frequent because of climate change. For example, from 2017 through September of 2022, the U.S. has experienced 104 separate billion-dollar disasters. By comparison, from 1987 through 1991, there were only 15. Bringing the JPSS-2 satellite to launch pad has been a true team effort amongst NOAA, NASA, and our industry partners who have built the JPSS instruments, satellites, and ground system. Further, we are eager to support our international partners with these global observations as we work together to understand our whole Earth system. So in just 4 days, we'll see the hard work and sacrifice it took to build and launch the JPSS-2 come to fruition. Congratulations to the JPSS program and the entire launch team. Thank you very much. Back to you, Megan.
Thank you, Irene. The number $104 billion disasters, that really puts into perspective how important JPSS-2 is and how important weather satellites are. So thank you for that. Tim.
Great. Thank you, Megan. And good afternoon and welcome everyone to today's pre-launch briefing for NOAA's JPSS-2 satellite. I'm Tim Walsh. I'm the NOAA Director for the Joint Polar Satellite System Program. It's an integrated program with our partners at NASA. Perched 191 feet above on an Atlas V launch vehicle just a few miles away, JPSS-2 is the third satellite of 5 that will join the other 2 satellites in orbit on the 1330, it's just an early afternoon sun-synchronous orbit. And it will be used, and this will be these constitute the next generation of low Earth orbiting U.S. weather satellites. The JPSS program is very excited to share our ride to orbit with the LOFTID program, which you'll hear next very shortly. Yep. These JPSS satellites provide high precision Earth observations that inform the U.S. public every day. Whether you're preparing for devastating severe weather such as floods, hurricanes, and/or droughts, or just checking next Monday's weather to see if we're going to be launching, to see if how the weather looks in the morning. These satellites also add valuable information to climate records. For example, they give us long-term records of the temperature of the atmosphere and show us how it's changing. After the satellite and instruments are checked out, JPSS-2 will observe every place on Earth at least twice a day, as the satellite orbits the Earth pole to pole 14 times daily. To predict local weather, we need to observe the weather from this global perspective. A dust storm in Africa can affect the development of a potential hurricane that might impact the East Coast. A typhoon in Japan might result in a heavy rainfall here in California just several days later. The JPSS-2 satellite will carry 4 key instruments into orbit. The Visible Infrared Imaging Radiometer Suite, or VIIRS, is essentially the eyes of the spacecraft, the eyes of the satellite. It measures the Earth in the infrared and visible part of the spectrum, and it gives us images of hurricanes, floods, dust storms, cloud patterns, and ocean color. It is also used to locate and map wildfires and track wildfire smoke. The Advanced Technology Microwave Sounder, or ATMS, observes passive radiated microwave energy from the Earth to see through clouds and inside storms. The ATMS, in conjunction with the Cross-Track Infrared Sounder, or CRIS, gives weather forecasters a global 3D picture of the atmosphere's temperature and moisture profile, the most fundamental information required by our numerical weather prediction models. Our fourth instrument is the Ozone Mapping and Profiler Suite, or OMPS. The OMPS tracks the concentration of ozone in the atmosphere. Data from OMPS is used in ultraviolet index forecasts, which is used to keep the public informed about the harm of UV radiation. OMPS also provides valuable measurements of stratospheric aerosols, such as those caused by volcanic eruptions and wildfires. JPSS is a collaborative effort between our partners at NOAA, between NASA and NOAA. NOAA funds and manages the program, performs operations, and provides the products to the user community. On behalf of NOAA, NASA develops, builds, tests, launches, and hands over the spacecraft to NOAA roughly 90 days after launch. And NASA developed the ground system, and NOAA now operates and maintains that ground system for the JPSS program. I really, really want to extend a heartfelt thanks to the group here in front of me, and also represented by the NASA NOAA teammates across the nation, across the world, actually, with our international partners. And I do want to, I recognize that in the last 3 years, it's been particularly difficult to take the satellite to the finish line, and now we're just 3 days away from launch. I'm so excited about that. So thank you. Go JPSS-2. Back to you, Megan.
Thank you, Tim. And as you said, JPSS isn't going up alone. Jim, why don't you tell us about LOFTID?
Yeah, I'd be glad to. Thanks, Megan. And I want to thank everyone for joining us here today, in person especially, and also virtually. We're really excited to be here with all our colleagues getting ready for the launch of JPSS-2 and LOFTID. I want to thank especially all these partners of NOAA, NASA Science, and ULA for partnering with us to have LOFTID on this mission as a rideshare. LOFTID stands for Low Earth Orbit Flight Test of an Inflatable Decelerator. It's going to be a flight test of inflatable heat shield technology. To me, this is really cool technology. I love it. There's so many things that we get to do that are cool. And it's been in development for over a decade with previous smaller versions of flight tests of suborbital heights. Tuesday will be our first orbital flight test of the inflatable heat shield, as well as the largest heat shield ever to enter an atmosphere at 6 meters in diameter. It's 20 feet. And so I brought a prop, and I think we have a couple photos too. Yeah, so you can kind of see this is as it looks here. This is the fully inflated version of it. So it comes into the atmosphere, and you need to create a lot of drag. So as you're going through it, and this is the reentry vehicle. So this whole package fit inside here. Before it inflated and stuff, so you can kind of get a see of the packaging. This is about 1/50th scale, so 2% or something like that, if you want to imagine how that would be. And so the heat shield itself is really kind of amazing. It's made of flexible materials. Obviously, since it can package so well, it's like a woven thermal protection system, and the tubes are woven into a synthetic powder, a synthetic polymer. Look at it, right? That's 10 times stronger than steel by weight once it's inflated and stuff like that. And so it's the flexibility is what makes the technology so valuable. It can stow for launch. Inflatable heat shields then become larger to land heavier payloads on Mars, or return spaceflight components for low Earth orbit, lowering cost of access to space. So that's why it's a perfect partnership between NASA and ULA. It's a common technology that we can utilize to solve multiple problems. I do want to mention one person in particular that really made this mission possible. Bernard Cutter was ULA's former chief rocket scientist, I'd call him. He passed away unexpectedly in 2020. We wouldn't be here without Bernard. And so we're really honored to dedicate this demonstration jointly to Bernard. Tuesday's demonstration actually happened pretty quickly. That's kind of unusual in that our entire demonstration will take place 125 minutes, about 2 hours, a little over 2 hours after launch to the time we've had splashdown. After JPSS-2 separates from the upper stage and it's on its way to orbit, then LOFTID will inflate, re-enter into the atmosphere, and splash down within a few hundred miles off the coast of Hawaii. Recovery teams on a boat will head out there to recover the aeroshell and a backup data recorder that we'll eject. So we don't absolutely have to we certainly want to recover the whole system, but we don't absolutely have to. The data is the most important thing, and so we have data that's coming that is real time that will be collected to the extent that we could with the bandwidth we have. We have a data recorder on the unit, the system, and so if once we recover that, then we'll have that. But we're also have an ejectable that's designed to float in the water. Recovery teams will head out there to recover the aeroshell and the backup data recorder, and then we'll be able to evaluate how LOFTID performed. And so that will really help to improve our designs, increase our reliability for future versions of technology. This is just the start as we go through it. And that's why our technology demonstrations are really so valuable, and this is one of the best ones we have. So we're looking forward to the demo, the ways it helps us in the next step in exploration, and back to you, Megan.
Thank you so much, and thank you for mentioning Bernard Cutter, the one of the dedications on board this mission. There's also a second dedication from Mark Levesque, and you'll learn more about both men during our launch broadcast, which we'll have during the launch. Okay, last but not least, Captain Zounes. You kind of alluded to maybe not so great weather.
I wish I had better news. But before I get to my weather brief, I would like to discuss expectations for November, especially for the members who don't live in California. Those of you who have been around the past couple months, you've noticed that we've had morning clouds, afternoon hot sun, and then sometimes we get a monsoon thunderstorm that rolls through like a couple weeks ago. That is transitioning out, and we're moving into November and winter time where we start to get low pressure systems and fronts to push from the Pacific Northwest down into California. Those often bring elevated winds, precipitation, clouds, and occasionally cold core thunderstorms. That's not going to be an impact for this launch, but the first three might. So we often get roughly 2 to 3 fronts per November that lead to roughly 6 to 8 mornings where we have pretty windy conditions. So now that I've set expectations, let's move on to the forecast. Could you bring up satellite, please? As you can see, we have a low over in the Gulf of Alaska with a front that drapes down from Canada down to southwestward to over the central Pacific. Now that's going to be the main feature that pushes in over the next 4 days. However, what's really going to impact the primary day is going to be that green swath of moisture highlighted connecting from Hawaii to Seattle. So what's going to happen is that is going to push all that moisture over us around T0 during the count, and that's going to lead to what's called a thick cloud rule violation. If you would like to show the forecast for primary day. I have a 40% chance of go. I know that's not what you want to see, but and you guys might be wondering, wow, thick clouds, who cares? The thing is that even though it might not impact your daily lives, you don't need a jacket, you're not going to worry about a thunderstorm getting struck by lightning, it does impact a rocket. And to explain that, I need to explain the difference between rocket-triggered lightning and natural lightning. Natural lightning occurs when you've got a cloud that's has a strong enough electric field that generates its own lightning strikes. However, rocket-triggered lightning occurs when a cloud has an electric field that's not strong enough for lightning, but if you add a conductive object like a rocket to the electric field, it enhances it, and that's how you get a rocket-triggered lightning strike. Now, the thick cloud rule is one of the conditions where that can occur. It's when you have a cloud that's relatively thick with lots of mixed phase particles, so you're looking at temperatures between 0 and minus 20 Celsius, and that is enough of a condition for those rocket-triggered lightning strikes to potentially occur. What we're forecasting is a roughly 10,000-foot thick cloud with temperatures between minus 11 and minus 20. Now, if the cloud is completely colder than minus 15, that's just ice crystals, no mixed phase particles, so you're not expecting to have a strong electric field, statistically speaking. But we are expecting it to be in that temperature range where it could be a threat. So I've put in a 40% chance of go, which is a 60% chance of violation. The definition of that is that it's more likely to happen than not. It's not higher because while we are confident that this condition is going to occur, there is significant difference in our weather tools with regards to the timing. It's going to last roughly 6 to 12 hours, but somewhere between 6 p.m. and 6 a.m. on Halloween night to Tuesday morning. So as we get closer to the forecast, I will either increase or decrease the POV based on our certainty and the consistency in our tools. That's the only threat on primary day. One more thing. Upper level winds, sorry. We're looking at the winds being out of the west-southwest, roughly 70 knots. Safety has demonstrated that is not at above risk levels at the moment, but if that increases a little bit, that might be a problem. The reason that's a problem is if you get winds out of the west-southwest and there's a non-nominal launch, then what you could end up with is the debris pushing over populated areas. So we want to be careful about launching into conditions where you have winds from that direction that are strong. Now, if you would like to show the backup day, unfortunately, it's not a whole lot better. It is a little bit better, but not a whole lot. What happens is once that moisture moves out, we're going to get that front to push through. Now, that front is going to cause precipitation, elevated winds, thick clouds like usual, but also disturbed weather, which is elevated particles with that precipitation. That can lead to rocket-triggered lightning as well. The reason why it's lower, as in 40% chance of probability of violation or 60% chance of go, is because there's a less consistency on the timing of the frontal passage. It's only going to last 3 hours. But again, somewhere in that 12-hour period, once the models, our weather tools get more consistent on the exact timing, then we'll be able to adjust the POV probability of violation accordingly. We are also looking at increased ground winds. Luckily, they're from the northwest, which is going to be our most tolerant direction. We don't want the rocket to tip over, but luckily from the northwest, it is sheltered a little bit more. So we are looking at steady 11 to 17 miles per hour with gusts up to 25 miles per hour. It's not as well below the threshold, but looking at 43 different past weather events that are similar, this is certainly much weaker than those, and all of those cause violations barely. So we are looking at probably not violating ground winds, but there's always a chance that the models could show it strengthening as we get closer. I will continue to monitor it, but unfortunately we're looking at potentially active weather. Back to you, Megan.
Thank you, Captain. This is a pre-launch briefing for a weather satellite, so I expected the weather briefing to be very detailed, so I appreciate that. All right. No, don't apologize at all. So thank you, everyone, for your opening remarks. It's time for some questions. So, again, if you are in the room and have some questions, just raise your hand. Or if you want to get off the question queue on the phone, hit *1. And I do know we actually have a lot of social media questions coming in already, so let's take the first one, if you don't mind. Allison?
Our first question from social: when was JPSS-2 built?
So I'll take that. I think, although the JPSS program has been going on since 2010, roughly, it's been before that. It was named from another program, but the satellite takes roughly about 5 years to build. The last 2 years have been really environmental tests. So you have to bring all the components together. You have to bring instruments from 4 different locations. We integrate them in one location. In this case, it was in Gilbert, Arizona, at Northrop Grumman. And by that time, we have an environmental test campaign, and now we're ready for launch.
Great. And actually, Allison, keep the mic, because I know we have a lot coming in, so go ahead.
Awesome. Yeah, another JPSS-2 question. Where exactly is it going? Can you tell us more about the orbit?
Yes, it is in something called a polar sun-synchronous orbit. So we're going to go at a slightly retrograde orbit coming off. We're going to go due south, or nearly due south, when we leave on Monday or Tuesday morning. And we're going to be in something called this sun-synchronous orbit. Means that basically relative to the sun, the plane of the orbit doesn't move. And so therefore, when it comes up, you hear something called the local time of ascending node. Every time it crosses the equator going north, it's at 1:30 p.m. local solar time, and so therefore that information is very important to the users that use our data, because it's that time of the afternoon is when the weather starts to really kick up. We have partners in Europe that build another satellite that is also in a different orbit, but it's in the mid-morning orbit, and so therefore by getting these spatially distributed measurements, we can actually integrate them into our models and give us better forecasts.
Yep, you again.
All right. Now a LOFTID question. When will LOFTID return, is it going to be recovered, and if so, where?
Yeah, LOFTID, this mission is actually very short. And so about 2 hours after launch, it will be splashing down just off the coast of a few hundred miles off the coast of Hawaii. The intent for us, the plan for us is to we have a ship ready to go collect it and retrieve it, as well as a separate data recorder that's ejected, so we have a dual chance, or triple chance actually, on the data itself.
Okay. Any in the room here? I do know we have reporters here. Okay, again, if you are on the phone, we do see a couple of you on the phone. To ask a question, you have to hit *1. Okay, this is one from social media, so sorry about that. What is the biggest challenge with this mission? It's a unique mission. It's 2 missions at once.
I can go first, I guess. I do believe that the integration of the LOFTID and the JPSS payload, I saw a NASA press release that called it a super stack. And so it's a unique orientation or system that we've put into this rocket, this last one from Vandenberg, the last Atlas, I should say. But I do think that the most difficult part is making sure that every instrument works perfectly. And we do such a rigorous, we have to make sure that these last in orbit they last a design life of 7 years, but we expect they usually last much longer. And so we try to make sure that we test them thoroughly and make sure that they're completely functional when we launch. That's, to me, the most difficult thing, is to make sure that we've checked every box to make sure that we're ready for orbit. I do want to just go back on one comment earlier, is I did say that to build a satellite it would take roughly 5 years, and that's not truly indicative of the development time for these instruments. And I do want to emphasize that something of this complexity usually takes almost 10 to 15 years to build the instruments, to design them, design the spacecraft, and launch. I was referring specifically to J2 when everything came together as roughly the last burst of energy is that 5 years.
And I'll add also to that question in terms of it's almost always the integration that is the hardest thing to do, right? And in our case, it's the integration of this inflatable decelerator into the reentry vehicle and timing and stuff like that, and then especially the integration with our partner in ULA. They're providing some of the hardware that goes into this demonstration. They're providing the launch and the integration to that stuff. And so that part, it's a tremendous partnership, but it's always the most complex thing.
Jim, this is a question, I believe, for you. You know, LOFTID is the largest blunt object to reenter. How does this compare to shuttle?
Let's see. I don't remember how
We'll have to get back to you. That's okay. Sometimes these social questions.
But 20 meters, well, let's see. Well, the payload, we'll get back. I'm trying to remember the payload bay.
No worries, no worries. I do see a hand in the room here. Give us 1 sec. We'll get the mic over to you.
Hi, this is... Oh, okay. Hi, this is Karen Cruz Orduña with KEYT. My question is, you mentioned about integration and so forth. How crucial was that, during this process? How crucial was it to have those 2 integrated in this mission?
I would say, well, first of all, there's 2 missions that we're integrating, correct? But there are also four instruments that come together with the satellite. So there's a number of different integration points that are so critical, one of which is we've been working with LOFTID for a number of years, but primarily understanding the interfaces between their mission and our mission. The satellite itself, the definition of those interfaces is so important. We're actually launching 4 instruments that are previously on the NOAA 20 spacecraft and previously to that on SNPP. They're now on a different spacecraft, so the integration is a first of its kind for this mission.
And if you don't get it right, even some small detail, the mission fails.
Okay. We have another one from social. This is for you, Omar. Of the 100 missions, which one stands out the most for you, or which one's your favorite?
Oh, boy. It's like asking me which is my favorite child. I don't know. I could span a lot of missions. I could tell you the most difficult, the easiest, but the sexiest ones are the Mars rovers, and I've been a part of that since Sojourner. So, and I've had the great opportunity to launch every single one of them since Sojourner as the launch director for them. So those have a special place in my heart. And it's cool that you can pass that on to to the whole world. It's not just us in our nation. It's the whole world going to another world, and that's something else. But I could sit here for hours and talk to you about Pluto New Horizons and how fast that was leaving the Earth and how difficult that was to get off this planet. And other missions like ICON that were tough to get off this Earth too. And yeah, it goes on and on. So I don't have favorite children. I just have great, fond memories.
Well, what I think is so cool about the Launch Services Program is you guys do launch a lot of science, very diverse science. So really, you've left your impact on a lot of the research that's happening on Earth. So
yeah, some of that has, you know, when we look back at where this where JPSS is going, it's flying information with other spacecraft that we had a part in launching, and it's fantastic to see that hey, we were a part of all these other missions that are flying information and getting this vital information to get the Weather Service guys the tools they need to do their guessing. So it's awesome.
Right. Oh, we have another one in the crowd here.
So I know on social media there was a question of what was the biggest challenge. What was the biggest highlight of this whole, trek?
I'll take that one. I remember, this maybe relates to a challenge, but I remember 2.5 years ago when we entered the pandemic. It was a tremendous challenge for everyone in the world. But, when you look at what it takes to build a satellite, right? I mean, you need people there on site physically working on the hardware. And there were a lot of people in those early days that put themselves at significant risk, because they were dedicated to the mission. They knew that this mission was vital for the health and safety of Americans. Excuse me. And so they went in, to the office, and they went into the labs and the clean rooms, and they made sure this thing was built and it was tested and it was going to work. And I think it's tremendous how our entire community mobilized to bring this system together against those huge obstacles that we're all familiar with.
Great question. Thank you so much. And then we have a question right here. Can we just, yep.
Thank you. Hunter Kilpatrick, HKP Space News. I have a question about LOFTID. Is there a simulated mass that LOFTID is carrying, and if so, how much weight is that?
The entire package is around 2,500 pounds. And there is, whether it's a simulated mass or something, this is, it's a large percentage of it is in that.
Thank you for that question. We have another one from social media, so can we get that mic over to Allison over there? Thank you.
Awesome. All right, and this one is for Gary. What do you plan to do with the Space Launch Complex 3 after you launch the last Atlas V?
That's a great question. Space Launch Complex 3 will actually be used to launch our Vulcan Centaur. So after launch, the team's going to start deintegrating and safing all the hazardous systems so that we can come in and make significant modifications to the platforms, to the facility. The Vulcan Centaur is using different commodities, so we have to run those feed lines in and make those up to the launch platform. So we're going to start a significant deintegration and then manufacture a capability to be able to launch Vulcan Centaur with an initial capability early in the spring of 24.
Okay. Well, thank you so much, everyone. That is going to end our news conference. Thank you to those who asked questions as well as to those who answered it from our dais here. We will have another briefing tomorrow at 1 p.m. Pacific time, and that one's going to go a little more in depth about the science behind both JPSS-2 and LOFTID. And then, like I said, Tuesday's 36-minute launch window will open at 2:25 a.m. Pacific time. Live coverage will begin on NASA TV and its YouTube and social media channels 40 minutes before, so that's 1:45 a.m. Pacific time. In the meantime, you can find out more about each mission if you follow the websites you see on your screen there. That's noaa.gov/JPSS2-launch. And then there's also nasa.gov/LOFTID. Okay, again, thank you so much for joining us, and we'll see you on Tuesday.